Hey guys, Mr. Backerberg here. In this video, we're going to look at rewriting equations and formulas. So what we're going to work on doing is writing equations in what's called function form. So an equation with x and y in it is in function form when the dependent variable, or your y variable, is isolated all by itself on one side of the equation. So what you're going to end up with is an equation that says y equals, and then it's going to have some other stuff on the right-hand side of that equation. That is what's called function form. So in this example, we've got the equation 3y equals 6x plus 12. And like we said, our goal is to get this written in what's called function form, which means that we want to get the y all by itself. So we want to look at what's happening right now and try to isolate that y using inverse or opposite operations, just like we would if we were solving an equation. So with that 3y, there's nothing written between the 3 and the y, so that means we have multiplication happening. So in order to undo that times 3, we're going to have to divide both sides by 3. So I'm going to divide by the 3 on the left-hand side. Now we have to be really careful because on the right-hand side, when we divide by the 3, we have to remember to divide everything in the equation by the 3. So I have to divide the 6x by the 3, but I also have to divide the 12 by the 3. So now on the left-hand side, the times 3 and the divided by 3 are going to cancel each other out, leaving us with just a plain y equals. If we take 6x and divide it by 3, well, 6 divided by 3 is 2, but then we have that x attached to it. And then if we take the 12 and divide that by 3, we're going to get 4. So we get the equation y equals 2x plus 4. In our next example, we've got the equation negative 4y equals 2x plus 8. So very similar to the last one we saw. There is a number or a coefficient in front of my y variable right now. So we're going to work on getting rid of that. There is multiplication happening since the negative 4 and the y are written right next to each other. So in order to get rid of the times negative 4, we need to divide everything in the equation by the negative 4. So on the left-hand side, the times negative 4 and divided by negative 4 will cancel each other out, leaving us with just a plain y equals. Now, on the right-hand side, when we look at the 2x being divided by the negative 4, 2 doesn't divide nicely by 4, but that is a reducible fraction. 2 over 4 can be reduced down to 1/2, but this is going to be negative 1/2 because of that negative 4. We still have our x attached to it. Now, when we take this positive 8 and divide it by negative 4, we should get negative 2. So we have minus 2 on the back end of that equation. So we get the equation y equals negative 1/2 x minus 2. In this example, we've got the equation 7x plus y equals 12. And again, we're focusing on getting this written in function form, which means we want to have the y all by itself. So if we look at where the y is located, we have that extra 7x on the left-hand side with our y. So we're going to want to move that 7x over to the other side of the equation. Now that's a positive 7x, so to move that across the equal sign, we're going to have to do the opposite of that, which means we're going to have to subtract 7x from both sides. So I'm going to subtract 7x from the left-hand side, but I'm also going to subtract 7x from the right-hand side. So on the left-hand side, those 7x's are going to cancel each other out, leaving us with just y equals. Now the 12 and the minus 7x are not like terms, so we can't combine them. So I'm going to write it as negative 7x plus 12, since we've got a positive 12 over there on the right-hand side. So we get the equation y equals negative 7x plus 12. In our next example, we've got the equation 3y minus 9x equals 21. And again, we're trying to get this written in function form, meaning we want to get y alone. So if we look at what's happening on the left-hand side, the first thing we're going to work on getting rid of is that minus 9x. So in order to get rid of a minus 9x, we're going to have to add 9x on both sides of our equation. So on the left-hand side, the minus 9x and the plus 9x will cancel each other out. So we have 3y equals, now I'm going to write the right-hand side as 9x plus 21. But now we still have one more step we need to do in order to get our y alone, because we have that 3 in front of it. So we are going to divide everything in this equation by that 3 in order to get our 3 in front of that y to cancel out. So we get y equals, now when we take 9x and divide it by 3, we get 3x. And if I take 21 and divide it by 3, we get plus 7. So we get the equation y equals 3x plus 7. In this example, we've got the equation 6x minus y equals 8. And again, we want to try to get our y all by itself. So on this one, I'm looking at that 6x. And to move that 6x over to the other side, what we're going to have to do is subtract 6x on both sides of that equation. So the 6x and the minus 6x cancel each other out. So now we're going to have negative y equals negative 6x plus 8. Now there is a number still written in front of this y. It doesn't look like a number's there, but having that negative out in front really means we've got negative 1 times our y. So in order to get rid of that negative 1 being multiplied by our y, what we need to do is divide everything in our equation by negative 1. So that's going to cancel out the negative 1 that's in front of my y, leaving us with just a plain y equals. Now, if I take negative 6x and divide it by negative 1, that turns that to a positive 6x. And if I take a positive 8 and divide it by negative 1, that turns that into a minus 8. So we get the equation y equals 6x minus 8. Last example we're going to look at here, we've got the equation negative 3y plus 2x plus 12 equals 0. Our goal, again, is to get our y all by itself. But notice there's a lot of things on the left-hand side with that y. So in order to make this a little bit quicker, I think I'm actually going to move that minus 3y. So in order to get rid of a minus 3y, what I'm going to have to do is add 3y on both sides of my equation. So the minus 3y and the plus 3y cancel each other out. So we get 2x plus 12 equals 3y. Now we want our y to be all by itself, and right now we've got that 3 in front of the y. So in order to get rid of that 3 that's attached to the y, we're going to have to divide everything in this equation by the 3. So on the right-hand side, the times 3 and divided by 3 will cancel out, leaving us with just a plain y. On the left-hand side, 2 doesn't divide nicely by 3, so I'm just going to leave it as the fraction 2/3 x plus, now 12 divided by 3 is 4. I am going to make one more change to this equation, though, because typically when we're writing things in function form, we like to have the y variable on the left-hand side. So what I can do with this, now that I've got y all by itself, if I want to get y on the left-hand side, I can take this whole equation and just flip it around. So then we would get y equals 2/3 x plus 4. So it's the exact same equation from the step before. We just switched sides on everything. That's going to be it for this video. Thanks for watching.